First of all, magnets got their name from a region of Magnesia, which is now part of present-day Greece. The first lodestones, which are naturally occurring magnetic rocks, were found in this region almost 3,000 years ago. A lodestone is composed of an iron-based mineral called magnetite. A magnet has magnetic poles, which is one of 2 points such as the ends of a magnet that have opposing magnetic qualities. All magnets have at least one pair of poles, a north pole and a south pole. The poles of magnet exert a force on each other. The 2 poles are north and south. 2 like poles repel each other. 2 unlike poles attract each other. It is also impossible to isolate a magnet or cut it in 2 halves or more pieces. Each piece will still have 2 poles, no matter how small the pieces of magnet are. Some substances, such as lodestones, are magnetic all the time. These magnets are called permanent magnets. You can change any piece of iron, such as a nail, into a magnet by stroking the iron several times with a magnet. Some materials retain their magnetism better than others do. Scientists classify the materials as either magnetically hard or magnetically soft. Iron is soft magnetic material. A piece of iron is easily magnetized, but it also tends to lose its magnetic properties easily. Unlike iron, cobalt, and nickel, they are hard magnetic materials. They are difficult to magnetize. However, these materials do not lose their magnetism easily. Magnets exert magnetic forces on each other. When a magnet is dipped into a bucket of nails, the magnet can pick up a chain of nails. Each nail in the chain is temporarily magnetized by the nail above it, so then it will become a permanent magnet. Have you ever tried putting a magnet south pole toward another magnet south pole? Have you ever noticed that they don't attract? Well, it's because of the magnetic field. The magnetic field is a region where a magnetic force can be detected. Magnets repel or attract each other because of the interaction of their magnetic fields. As you can see in this image, the magnetic field lines always form closed loops. Also, compasses always align with Earth's magnetic field because it has magnet north and south poles, and it's attracted to the magnetic fields, poles of Earth. Earth's magnetic poles are not in the same place as geographic poles. Earth's magnetic field lines run from geographic south to geographic north. The pole in Antarctica is actually a magnet north pole, and the pole in northern Canada is magnetic south pole. As the poles locations are changing over years, well, now it's in Antarctica in the north, and it's northern Canada to the south. And as you can see in this image, it shows the different strength of the magnetic poles on different locations on Earth. For years, scientists have speculated that some birds, such as the geese, use Earth's magnetic field to guide their migrations. Magnetic particles that seem to have a navigational role have been found in the tissues of migrating animals such as birds, bees, and fish. Special thanks to Mr. Muhammad Ibrahim for supporting me in doing my video. Thank you. I hope you understood the lesson.